Hey guys, it's Mrs. Miner and I'm here with part 2. We're going to do electrophilic addition mechanisms, but this time we're going to use hydrogen halides. So here's our overall reaction. We have an alkene and we're going to put a hydrogen bonded to a halide ion onto it. The hydrogen will go on one side and the bromine will go on the other. And so that's what we learned back in HL1. So remember that these guys are flat triangles, right? And because of that, an electrophile, so this would be something that's seeking those electrons or it has a positive charge, can go to the front or it can go to the back. So that's why these double bonds are super, super easy to break. Okay? So this is a two-step mechanism, and if you watched part 1, this is going to be very, very similar. The biggest difference, though, is we're starting off with a polar molecule. So my hydrogen is partially positive and my bromine is partially negative. So I don't need an induced polarity here because of that double bond. That polarity already happens. So because of that, I'm going to have this place of negative charge, which is that double bond. So remember, there's lots and lots of electrons that are gathered in there. And it's going to be attracted to the positive part of this molecule mate. It's the electrophile. Well, if you remember from part 1, when this happens, it's not just that like one electron is now available. That bond is actually going to break and open, and this gives the hydrogen a place to attach onto. So the hydrogen doesn't need its electrons anymore, and it's going to send its electron that it bonded with to that bromine. So on the other side, that's going to look like the bromine over by itself with its extra electron, and now it has a negative charge. And we're going to have our alkene, but its double bond has now come down and grabbed that original hydrogen. Now, when this happens, realize I have a place where I should have electrons, but I don't, and that creates a positive charge. And our word for that is carbocation, and we're going to call it an intermediate because this is a two-step mechanism. This is made in one step, and we're going to use it in step 2. So we're going to go ahead and come down here. This is the fast step because now we already have this negative charge on the bromine with its 2 electrons, and we can create a dative bond where we're giving both of those electrons to that carbon. So here on the other side, we're going to have that added hydrogen is going to stay where it was. And this bromine is going to add on there. So we're going to get bromoethane. Hope this works for you guys because my cat is about to knock my notebook off and my children are screaming. So I hope you're having a good day and hopefully I'll get to see you soon.